So of course I want to start by saying thank you everyone for joining. My name is Cody Armstrong, and today we're talking about advanced part modeling in Onshape. Now, before I begin, I always like to start these webinars by mentioning again that these are really your opportunity to ask any questions that you'd like. So there's questions dialog in the GoToWebinar control panel. Feel free to ask any question, and I'll do my best to stop and address these. We like to do these webinars really as an opportunity to interact. So please feel free to ask any question, and I'll do my best to stop and address them as we go through today's webinar. Now, the topic today is advanced part modeling, and that can mean a lot of things to a lot of different people. So I want to make sure to set an expectation. First off, I want to stress that this is really not intended for those that have many years in CAD and many years, potentially a lot of time built up in Onshape. This is really intended for those that are trying to get that next step past our essentials. And in our essentials, we cover kind of the basics of sketching and, simple extrude features. So in our advanced part modeling, we're going to cover a lot of the things that we don't get an opportunity to cover in the essentials. Commands like revolve, sweep, loft, patterns, shell, those important part modeling commands that you need to know, but that we don't get an opportunity to cover in essentials. So really intended for those still new to Onshape, but trying to understand some of those more advanced commands. Advanced has a different meaning to everyone, but just realize really intended for those still getting started and are interested in the details of revolve, sweep, loft, shells, patterns, variables, the things you'll need to start really digging into part modeling. Now, before I begin, for those new users out there that are just picking up Onshape, there's always a few things I like to mention. And the first that I like to mention is our mission statement, and that is getting everyone working together with CAD on any device, anywhere. This includes mobile devices, includes any computer, with a modern web browser. So you can access your Onshape data from Windows, Mac, Linux, Chromebooks, iPhones, iPads, Android phones or tablets, and you have a full functioning CAD application on any of those platforms. So again, everyone working together with CAD on any device, anywhere. That's our mission with Onshape. Now, of course, Onshape itself is professional 3D CAD. And when you think of professional 3D CAD, it's generally you think of parts, assemblies, and drawings. And we do have parts, assemblies, and drawings, but we have a lot of things that other professional 3D CAD systems don't. One of the things I always like to mention is our frequent updates. So what's really unique about Onshape is roughly every 3 weeks, you see new features being added to it. And the neat thing is you don't have to do anything, right? There's no downloads or installs or updates. You simply log in and new features will be there. So frequent updates is something that's very unique to Onshape and very unique to our architecture, something that allows us to push updates very frequently that you couldn't get if you're an installed software. The next thing I wanted to mention is built-in version control. So if you think about other CAD systems, oftentimes version control is handled by some kind of a PDM system, some kind of a file management system. That capability is built into the core functionality of Onshape. So you don't have to have a separate data management system to manage check-in, check-out, revisions, and so on. So built-in version control is a function that, again, is core Onshape. It's not something you have to manage separately. We also have the ability to import and export a lot of common CAD formats. So if you've come from some other CAD software, or if you have a library of CAD data in some other format, chances are we can import and work with that CAD data. It also means that we can export to common CAD formats, which means we work well alongside other CAD applications where, maybe I need to export to a certain format so that, this person can generate toolpath or something to that effect. So we work really well alongside other CAD applications, and we work really well with that library of CAD data that you've built up. Now, the next thing I want to mention, very important to Onshape itself, is entirely new methods of collaboration. So if you haven't shared your document yet, in the top right corner is a share icon. If you click that and you enter in someone's email address, define their permissions, you can share with them and work together in real time. And that's something that no other CAD system could do. You have the ability to collaborate with others, whether they're in the same room or across the world. And the model, anytime any changes happen to the model, it updates for everyone in real time. So live collaboration. So something very unique to Onshape and something that you should definitely try out if you haven't already. Definitely share your document and give it a shot. There's a lot of other tools built in as well, things like integrated comments and follow mode that really make that collaborative experience really great. So definitely share your document with a colleague if you haven't already and give that a shot. The next thing I want to mention is customization with FeatureScript. So FeatureScript is a programming language that Onshape developed that allows you to build your own custom CAD features. And so if you've ever had an interest in, maybe designing your own CAD feature that did a series of steps and saved you a lot of time, or maybe you wish you had an option in a certain command, chances are you can build it with FeatureScript. So Onshape has released the source code for our standard list of features: extrude, revolve, sweep, loft. We've released the source code for this, and you can take that and build your own custom feature. And it's something very unique to Onshape. Again, a programming language that allows you to build your own CAD features. If you're all interested in writing code, definitely check out FeatureScript. All right, so these are just some general things about Onshape that I always like to mention to those new users out there. What are we going to talk about here today? Well, I've already briefly discussed the agenda, but it's pretty straightforward. Think of this as a continuation of the Essentials webinar that we cover just about once a month, and that is, covering the basics of, getting started, the interface, sketching, and simple extrudes. We're going to take that to the next level with, of course, sweep, revolve, and loft, the 4 commands that you need: extrude, revolve, sweep, and loft. But then we're going to get into other commands: whole feature, shell, derived feature, patterns, variables, all the things that you really need to really start digging into part modeling. So that's the topics for today. Now, as I always say, again, feel free to ask any questions in the questions dialog in the GoToWebinar control panel, and we'll dig into it. But that is it for our slides. So let's jump right into it. Now, I'm going to start simple, and we're going to start with the revolve and sweep command. So I'm going to jump into a document here, and I have 2 examples, real simple examples of a revolve and a sweep to kind of give you an idea of the shapes that you can create, and then we're going to walk through actually creating one. So this is an example of a revolve. This is a simple pulley, for example, where it's a round shape, and that's an important thing to keep in mind with revolve. You're creating a round shape. The neat thing about this is you're creating potentially a very complicated part, or very, with a lot of different contours with a single sketch. And so the way to think of a revolve is if you take up a round part and you slice it down the middle, and you take just one section of that, you rotate that, that's essentially what a revolve is. And so you are sketching this slice section of what will be a round part. So that's a simple explanation of a revolve. I'm going to walk you through building this model in just a moment. But the next example I wanted to give is the sweep command. And like the name implies, this sweep command will sweep a profile along a path, which means a sweep command requires 2 things: profile and path. It's a bit different than extrude and revolve in that sense. It needs more than one reference. They could be 2 sketches, or more commonly, I would say 2 separate sketches to create a sweep. But again, you're taking a profile, like this circle in our example of this U-bolt, and you're sweeping it along a path, in this example, the U-shaped sketch that you see here. So 2 different sketches in our example, but you're sweeping a profile along a path. So that's the 2 simple examples that I have for revolve and sweep. Now let's walk through creating them. I'm going to start a new part studio here and start sketching. So I'm in a sketch on the front plane, and what I want to do is start sketching my revolve profile. And I would say the key thing when you're starting your revolve profile is just understanding what you want to rotate that revolve about, what we refer to as a revolve axis. And oftentimes that's where I'll start. It's not a rule, it's just a best practice, at least to identify, if not create, what that rotation axis is. And so that's where I'm going to start. I'm going to start with a line, then select construction, and then select a construction line, create a construction line that goes right through the origin. Right? So you notice that inference that I get there, left click, and now we have a simple construction line through the origin. The reason that's important is this is what we'll be rotating our sketch profile around to create that revolve part. All right, now I want to begin sketching the actual shape that I want to revolve. So again, I'll go back to the line command, and I'll just sketch a few lines. Right? So I'm going to create kind of the rough shape that we saw earlier. One big tip that I have as you're sketching, and this is not specific to revolve, but it's helpful in this example, is you'll notice as I'm sketching this line, vertical line here, I want this inference or referencing the point over here. I want this to be the same length as the one on the right. And what I can do is wake up the inference. I can move my mouse over that point, and then when I move back, you'll see it now wakes up that reference so that I don't have to come back and constrain that manually. Again, just a small tip, a sketch tip that applies really anywhere in Onshape, but you can wake up just about any point as a reference. I'll give you another example. Here, let's say I want to create a constraint relative to this point on the bottom so that it's the same length and I have a vertical line down. You can see it's not appearing here, right? So what I'll do is move my cursor over that point, move back up, and now I have that inference created. So you can wake up those inferences as you're sketching if they're not appearing by default. Now, a question that's come up, why 3D Sketch is not in here? We do not have 3D Sketch tools, that's true. It is something that's on our list of priorities. It's something that we're working on, but it is not yet available. All right, so I want to sketch a line solely to center this. As you can see, as I move these around, and if I start adding dimensions, I'm not going to get an even part. And what I want to do is I want to center this over the origin. So what I'm going to do is sketch another construction line, construction, left click the origin, create a vertical line, and now I have a construction line that I can create a symmetric constraint about. Now, another way you could have done this, and this is a bit of an aside, but you can also mirror the sketch and create that same symmetry. But we already have the whole profile, so we're going to select point, construction line point, and create a symmetric constraint. And what that will do is just give us that symmetry so that when we add dimensions, it remains centered. Right? Again, point, construction line, point, symmetric, point, construction line, point, and symmetric. So it's very easy to go in and add that symmetry so that when I start to add dimensions, it will stay centered. Right? So let's add a few dimensions. We'll add a dimension here, let's say 5. Right? Add a dimension here, let's say 6. And so all I'm doing is going in and defining a few of these widths for the part. 1. And you'll reach a point where you want to define the diameter. Remember, this is going to be a round part. We're going to take this profile and revolve it around this axis to create a round part. So when I start defining dimensions, if I were to select this line in the construction line, for instance, this value is essentially a radius, if you think about the finished result. And that's not really what I want. So a tip, and this is especially useful in sketches for revolves in particular, is you can move your cursor past that construction line and will automatically double the value and give you a diameter symbol. This is really practical, really useful in revolve sketches. So a big tip, use that construction line, move your cursor past it, and will automatically double the value and add that diameter symbol. All right, so I left click. Let's give this 2.25 as a value, and I can just keep going, right? Left click, and add that diameter dimension, right? Keep in mind that really useful for really understanding the design intent. If I had to dimension this in radius values, it would just look odd. It's not that I couldn't figure out what's going on, but it just would make less sense, right? Less practical. So here I've gone through and I've defined everything in the sketch, right? The width values and the diameter values. Again, moving my cursor past that construction line gives me those diameter values. And now I can take this and revolve it. Now, the Revolve command is fairly straightforward. You'll find it right here under Extrude in the toolbar. I don't even have to exit the sketch. I can go straight to Revolve. Left click. It will automatically select the sketch region to revolve. In this case, this sketch region, which is our profile. But I still need to define the Revolve Axis. You'll see a second dialog, second box here, and I need to select it. So I'll left click in that section of the dialog. Then I'll left click what is the Revolve Axis. Now, if you remember, when I started this, the construction line, that horizontal construction line here, is what I want to revolve this profile around. So I'll left click that axis, and there we have our finished revolve. Now, one last tip I would have for the Revolve command is you don't have to do a full revolve. You don't have to do a full 360. You can say, I want one direction, 45 degrees. Or I want two directions, 30 degrees this way. So you kind of get the idea. But my point in this is you can create kind of a pie slice section and not necessarily a full 360-degree revolve. Right. So that is the default, but you can choose the options here in the drop-down and choose how far you want your revolve to go. So I hit the green check, and there is my finished revolve. Again, think of that revolve as you're sketching that slice section of the round part, defining what that rotation point is, that rotation axis is, and then rotating around to create a round part. All right, so that's a simple intro into the revolve feature. Now, the next example I wanted to get into is something like this U-bolt. So in an example like this, the shape that we want is really a circle swept along a U-shaped path, and that's an ideal example where U-bolt would be the case. Why can't add standard triangle like equilateral isosceles, etc. in sketch mode, which is not in any of the standard softwares? No, it's not in any professional 3D CAD that I've seen, but it's, of course, very easy to sketch a triangle using 3 lines. One tip that I would have is if you want an equilateral triangle, sketch 3 lines that join each other in a triangle, and then window select them and set them all to equal. And that's an equilateral triangle. But of course, you can always just sketch lines. There's no specific triangle command. Can you tweak the dimensions and see the results in real time? Yes, you can. So a tip, this is kind of an aside, but it's a very cool tip. In any feature, really, a sketch or a feature, if you edit it, so if I right-click here and edit, you'll see this button that says Final. If you click this, you'll get the final result while still in the sketch, which means I can change dimensions. Let's change a dimension here for 6 to, say, 7, and it will update live. Right, so I can go through and tweak things, and it will update live, and I can see the end result. So this is a kind of an aside, but it's useful everywhere, and not just editing sketches, but also editing past features. You'll see this button for Final, and you can go through and make your changes and watch the model update live. Very, very useful, by the way, in the Loft command, because you do so much trial and error in Loft to get to straight profiles and guides and things. So very useful in a number of different situations, but particularly in the Loft command. All right, so what I want to do is give you an example of modeling this simple U-bolt. And as I mentioned before, if you think of a U-bolt, it's really a circular shape swept along a U-shaped path. It's an ideal example of the sweep command. So let's model this. I'm going to start a new Part Studio. And again, I'm going to start with a sketch on the front plane. Now, a quick tip that I have is, in general, not always, but in general, especially when you're starting from nothing like I am here, you generally want to start with the path. And that's not a rule, but it's just a best practice, and it makes things easier later when we talk about attaching things. But in this case, I'm going to start with a U-shaped path. So I'll just start with a simple line, and we'll start at the origin. Left click. We'll select a tangent arc next. Okay, left click, and then I'll finish with a line. Okay. So now I have my simple U-shaped sketch. I want to make sure that I have a tangent constraint between these two, so I'll left click, and we'll make them tangent. Then I'll add a few dimensions. So now I have a fully defined sketch. That's just the first step in my sweep. Remember, a sweep requires 2 things, a profile and a path. This is our path, but we still have to create the profile that we want to sweep along this path. And for us, that's going to be a separate sketch. Now, I would say many times in your scenarios, it's going to be 2 separate sketches. There are some exceptions where you might use an existing face or edges of the model to define one of these things, but I would say for the majority of situations, you're going to use 2 sketches, a path and then a profile. So I'll accept this first sketch. Just hit the green check. Here's sketch 1. And now I want to create the profile that I want to sweep along this path. Now, one big tip that I have, and this is very useful in the sweep command, I would say the majority of sweeps that you'll create will probably need this command. Not all, but a lot of them. And that is creating a plane. Inserting a plane at the end of your path. That's a very important thing. One big tip, probably the biggest tip that I have for the sweep command, is your profile must be attached to your path in some way, either with a coincident or pierce constraint. So that's a very important tip when you're creating a sweep. Make sure to attach the two. And one of the easiest and most common methods is to create a plane on the end of the path, sketch your geometry, and add a constraint attaching your sketch to that path. So let me walk you through an example like this. Now, in our example, in this example that I'm walking you through, I don't really have to do that. And the reason is because this just so happens to end right on the top plane. So you'll notice I started the sketch on the origin. There are, of course, planes going through the origin, so I could easily use one of those planes. But basically, anytime that you don't have a default plane at the end of your path, you'll need to create one. So how would you do this? Well, I would insert what's called a curve point plane. So I'll select the plane command from the toolbar, choose curve point, then choose my path and an end point of my path where I want to put that plane. And what will happen is it will put a plane, it will insert a plane normal to the end of your path, right? So I would say a very, very common command when you're doing the sweep, because again, generally you want that plane to be on the end of your path, right? So again, a big tip, if you don't happen to have a plane in the end of your path, you'll need to create one, and I would use the curve point plane option to do it, right? Now, it just so happens in our example, because we built it right on the origin, that we can just use the top plane, right? It's in the same position. Now, I'm going to start a sketch on the top plane, and as I mentioned before, we're really just sketching our profile. And if you look at our U-bolt example, it's really just a simple circle. So let's add that. I'm going to add a simple circle, and I'm going to deliberately sketch it kind of out in empty space. And I'm doing this just to show you the process of attaching it. So let's add a quick dimension here before we move on. Actually, let's make that a bit smaller. Now, I've defined my circle, the size of it at least, but I haven't defined its relationship to the path. As I mentioned before, this is a very important step of the process, probably one of the most important, and that is, again, I need to constrain this to this in some way. Now, in more complex sweeps, you may use a pierce command. In our example, it just so happens that the end point and the center point, I just want to bring them together, and I can do that with just a simple coincident constraint. So it can be either coincident or pierce, but you must attach your profile to your path in some kind of way, right? So that's really it. Once you've defined both sketches, you've constrained your profile to your path, you're ready to sweep. I'll accept this sketch and go straight to the sweep command. So sweep, again, you'll see two pieces, profile and path, faces and sketch region to sweep, and then the path to sweep them along. I'm going to select the circle as the sketch region to sweep, and then I'll choose the path as the U-shaped sketch. Now, one big tip that I have, you can choose individual pieces of a sketch. So if I don't want to sweep along the entire thing, I can do that just by left-clicking individual pieces. However, if your path is really long and you have dozens of lines and arcs, you're not going to want to select them one at a time. What I'd recommend is just choosing the sketch from the feature list, right? If you select the sketch from the feature list, it will automatically grab everything in the sketch and sweep your profile along all of it. So don't select them one at a time if you have a lot of them. Only select one piece of your path at a time if you only want to sweep along a certain portion of your sketch. But that's really it. You select your profile, you select your path, it sweeps that sketch region along the path, and you have your sweep. I hit the green check, and there we are. So again, your profile can be any shape that you want. We used a simple circle, but it can be just about any shape that you want to sweep along a path. All right, so that is a simple intro into the Revolve and Sweep command. What I want to get into next is the Loft command. As the number of features in a parts studio increase, the response time gets longer and longer. Any suggestions for speeding things up when you have a complex part studio? It really depends on a lot of the technique. So you can start to get into using like a derived feature to insert a part into another part. But it has a lot to do with the individual technique and the geometry created. There are a few general tips. I've actually done a forum post on this and just general performance tips that we can recommend, but avoid frivolous features, threads and really complex shapes, and heavy patterns tend to cause a lot of response time increases and things like that. But parting it out as well. So if you're modeling multiple parts in the same part studio, maybe taking those and making them their own separate part studio. There are a few techniques that you can use to really speed things up. But I say probably the biggest thing is, do you have any threads modeled explicitly? Do you have any large patterns, either at the sketch level or feature level? Those types of things tend to make a big difference. Now, of course, we're always working on speeding up in general Onshape. So whether it's rebuild time, load time, graphics response time, all of that stuff we're constantly working on. There's only a few things really that you can do on your end. And I would say breaking things up if necessary, if you're talking about multiple parts. Avoid the really complex shapes. I shouldn't say really, I should say a lot of faces. Heavy patterns tend to do it, and threads tend to do it. Anything that would generate a lot of faces in a single command tends to take a long time to rebuild. So just some general advice. I would do a search on the forum if you're really interested in the details. There was a whole forum thread. I responded to it. Alana, a member of our dev team, I believe, also responded to it. A very good thread. All right, so the Loft Command. Now, the Loft Command is very much a, I wouldn't say last resort, but it's very much a complicated command when you talk about with respect to a revolve and a sweep and a simple extrude. Think of a loft as a gradual transition between two profiles. And those profiles could be really anything you want. They could be circles, they could be squares. You can transition from a circle to a square. So it's very much a tool that allows you to create elaborate shapes, but it's also very much a tool that requires more time than you generally would spend on an extrude, revolve, or sweep. So in general, if you can create your shape using extrude, revolve, and sweep, you wouldn't use a loft. It just takes more time. But there are, of course, shapes that you can't create in those three commands that you can create in lofts. And that's really the key thing here. So it does take a bit more time, but the shapes that you'll need, you'll know when you need a loft. Now, there are a few things that we can do to make the loft easier. And I have a simple example here of a squeegee. And if we take a look at how this squeegee was constructed, if we jump back here to Loft 2, you'll see this is a shape. This is the handle, by the way, of the squeegee. This is a shape that we couldn't get using Revolve. It's not a symmetric round part. It has a contour on the bottom for the grip. So how do we accomplish this? Well, we use a loft. The loft is really just a loft between two circles, circle on either end, but it's controlled very specifically by two guides. Right? These guides control the shape as you're transitioning between what is essentially two simple circles. So just keep in mind, these kinds of shapes, loft shapes in general, will require multiple pieces. As you can see, I have two sketches here. I have two sketches here. 4 sketches to construct this handle, but you really couldn't do this any other way. Let me give you another example. I want to create the transition from the handle to, of course, the squeegee, the end piece of the squeegee here, which is just this, let me find the sketch here, rectangular sketch. Right, so I want to loft from this face to that square sketch, 2 very different contours. How would I do that? I can use a simple loft, select the face, and select, in this case, the sketch that I want to loft to. Now, in both of these examples that I've shown you, it's only 2 profiles, but keep in mind with the Loft command, you can have as many as you want. So if you think of more complex lofts, they may have dozens of profiles. Think of a boat hull, for example. It's a shape that's changing from front to back, and it's going to require a lot of different contours, all very close, but it's a gradual transition between them. And so in those situations, you may have a lot of profiles. So just keep in mind, a loft you can really spend a lot of time on, but you have the utmost control of the shape. Question, is it possible to show features like mirror, like sweep, loft? We will get into some of the patterns in just a bit. You can mirror sweeps and lofts if that's what you're referring to. Yes. And I will get into patterns in just a bit. Okay, so this is a simple example of a square to round transition, where I wanted to gradually transition from a circle to a square. Now, one thing I would point out about this is in this simple example, really in this example, I only created one sketch, the rectangle, and I'm lofting from this face. The problem with that is I really don't have a lot of control over the shape. If I look at it straight on, you can see that there's some twist in this shape that really isn't desirable, right? This doesn't line up exactly where I would want it to. If you look at this edge, it's kind of guessing. And the reason it's guessing is because a circle has no vertices, right? A square has 4. So it has to guess at where those transition points are, where it's going to map to the face, so to speak. So in a simple example like this, you may be fine with a twist. If it looks good to you, great. If it doesn't, then you're going to need to resort to more features, more creation of sketches in general. So let's roll up to the loft here and take a look at another example. So here I'm doing the same loft, but I'm controlling it with what we call guides. Now, guides are just sketch entities. Right? If I mouse over them, you can see them highlighted here. If I show them real quickly, you'll see they're just sketch entities, in this case just simple splines, that are used to control the shape of the loft. Now, you can use simple splines like I am here. You can use some of the more advanced commands that we have, things like, in particular, bridging curve, right? Or composite curve, if you want to bring together multiple entities and form a guide from it. But there are multiple commands that will create 3D curves that will allow you to control the shape of your loft very accurately. And I think the key thing with a loft is you want a smooth transition. More often than not, a smooth transition is very important, and a transition that you control. Now, of course, it's a lot more work to construct. If you look at this, 4 independent sketches with splines on them. So it's going to take more time, but of course, I control what that twist looks like, what the transition looks like, and it's very easy for me to manipulate it. Like we discussed earlier, and I mentioned this earlier as well, one very handy command when you're doing this kind of work where you have a loft and you're controlling it with guides is that final button. So if I jump into a sketch here, let's edit this sketch. Here I'm editing the guide associated with the loft. If I click final and I manipulate the guide, you're going to see the loft live update, right? And so especially in this kind of trial and error scenario where you're just playing with values, where I'm playing with a spline and seeing what it does to the loft, the final button becomes very useful. Otherwise, you would have you'd have to accept the sketch, look at the rebuild, edit the sketch, change it again, accept the sketch. You'd be constantly in this loop. All right. So the idea behind clicking final is you can do things like make these small manipulations and see how it impacts the overall design. So another big, and I've mentioned this earlier, but final's really useful in lofts for this scenario. Lofts tend to be, very much a trial and error thing in certain scenarios where you're trying to get this exact shape that you want, and you're manipulating these splines, maybe your curves, to get that shape. All right, so that's the loft command, and as I mentioned before, you have that option to control it with guides. Now, you also have an option to control it with what we call in conditions, and in conditions can be very valuable in an example where you want a certain type of maybe continuity between faces. Right, so I can define a normal to profile, and it will extend that normal direction of the face that I'm using. And I can even adjust the magnitude, right, and extend that out even further. So this is an easy way to control the shape without having to go through the effort of creating all those guides. You're inevitably just controlling it with magnitude and a series of conditions. But if you're lofting between faces and you're really, really concerned about the continuity between a face and something it's touching, this might be a good, useful tool, because you can do things like match curvature or match tangent, and that will give you that smooth transition from face to face, so to speak. Right? So you're not. I think the majority, I just don't want an abrupt, hard transition between the handle and this piece. This might be. The case for that. All right, so could you have mirrored the guidelines? No. No, you couldn't have. those are created on 2 different planes. You can copy and paste the guides, but you could not mirror them. They're on 2 different planes. Can the guidelines be mirrored upon a plane or an? Could the guideline? Oh yeah, same question. What I would do in that situation is I would just create 2 guides, create a half of the loft, and then mirror the whole loft across. That would be an easy way to ensure I have a symmetric transition. Why is the webinar always the same? Well, you have to keep in mind this webinar is intended for a new audience. We have lots of people who sign up for Onshape every day. And so this is intended for those that are just getting started with Onshape and have not attended this webinar in the past. We also do an Essentials webinar once a month to help those new users get started. All right, so that's a simple example of the Loft command. You have a number of options. As I mentioned before, you can really get into a lot of detail with the Loft command if you so choose. It really depends, how much control over that shape do you want. But end conditions can be very valuable. Guides can be very valuable. Also, if you're looking for symmetry in your geometry, there's an option for path. And I think for many out there, this will give you a simple way to create a symmetric loft about some kind of a center line. Right. So if you're looking for symmetry in loft, check out the path option and construct that path. We've also done videos, in great detail on this. If you're interested in more info on the Loft command in particular, we've done webinars in the past on the Loft command alone, entire hour on just the Loft. All right. So that is an example of the Loft command. Let's move on. Now, what I wanted to get into next and is an example of the whole feature. And it's just one of the commonly asked questions that we get. So we still have to cover whole feature, and then, of course, shell, bear with me here, derived feature, patterns, and if we have time, we'll get into variables. Now I'm going to jump into the shell command next. So bear with me for a moment here. Now the key to the shell command is what you're essentially doing is giving your part a uniform wall thickness. Very common if you're going for an injection molded part where uniform wall thickness is really a critical thing. I would select the shell command from the toolbar, and I'd select any faces that I want to remove after defining my shell thickness. In this case, this is the thickness that you'll have with the finished part, and I can click on any faces that I want to remove. What it will do is go through and add a shell feature that shells the part and creates that hollow part, so to speak. All right, so now you can see that uniform wall thickness. So very, very useful in a lot of different places, but particularly useful in things like injection molded parts, plastic injection, any scenario where you must have relatively uniform wall thicknesses. This can be a big thing. Right. So to give you an example, here is what that shell has accomplished for us. You can see now we have a hollow part on the inside here. So that is a simple example of a shell. Now, one commonly asked question about the shell command is, do you have to remove a face? Can I just make a part hollow? Right? On the outside, you wouldn't be able to tell the difference, but it wouldn't be solid, it would be hollow. And the answer is yes. If you edit the shell, there's an option for hollow. And if you check this, instead of clicking on a face to remove, you're just saying this is the part I want to make hollow. So you don't have to remove a face if you check hollow and then click on your part. Okay. All right, so that is a simple example of the shell command, a very easy to use command. The key is what is your wall thickness and what part or what faces do you want to remove from what part. All right, so let's move on. Now, the next command that I wanted to get into is the derived feature. Now, this is a very useful command in a number of different examples. I mentioned before you can take parts and bring them into other part studios, maybe to finish them or to do continued work or maybe build a variation of it. Another example that I give often is, let's say someone sent you a CAD file. Someone sends you a step file, an IGES file, a Parasol, whatever it is, even SolidWorks or Inventor or Creo CATIA, and you need to work around that file. You need to design something around that file. Well, you could do a derived feature and insert the part into a part studio and then model around it. Now, there are a few examples where this is useful, and we can get into even more advanced examples of this. And I'd recommend if you do a lot of designing around multiple parts, do a search for in-context design as well. Do some research on in-context assembly design. But if I'm sent 1 or 2 parts and I need to model around those parts, derived is really useful. Now, here's an example where I have essentially 2 parasolid files that I was sent. You'll see bottom casing and top casing, just simple parasolids that, of course, Onshape translates, and you can see here in the Part Studio. What I need to do, I've been sent 2 separate parasolids. I need to bring them together and then model a base for it or flange for it or some kind of part that's relative to these 2 parts. In this example, I would use Derived to accomplish this, right? So I'd go into a blank Part Studio, and the first step is I want to insert those 2 parts into this Part Studio. So I'd choose the Derived feature in the toolbar. You'll see it in the far right here. And then I'd choose the parts that I want to insert. Right? In this case, we'll choose the bottom casing, and then we can come in and choose the top casing. Keep in mind, they will be inserted into your Part Studio in the orientation they were originally modeled. And you may not have control over that, right? So you may need to do something like a transform to move the part around, especially if you're bringing 2 parts together. But keep in mind, they will be inserted into your Part Studio in the same orientation they were originally modeled, depending on where that is, with respect to whatever origin they were modeled in. Now, if they don't come in the right way, I would recommend a transform with mate connectors. That's probably one of the easiest ways to position parts in the Part Studio. Right? Now, again, if you have a lot of parts, I would recommend pursuing in-context assembly design, which we're not going to cover here, but we have done webinars on the past. So if you want, definitely check those out. But that's when we get into more complex, many parts or moving parts where transform just isn't practical. All right, so we've inserted our 2 parts. They came in the right position because they were originally modeled this way, but again, you may need to use something like a transform to position them. Now what I want to do is build my part. Now that I've inserted both of the parts that I need and they're in the correct position, I can easily model around them, right? If I want to build a flange, for instance, I can do that. And I don't have to spend a lot of time measuring values, coming back to a blank part, adding the value, measure another value, come back to a blank part. You can kind of see the flow here. So I can easily select edges of the model, convert them with the use command, right? I can sketch geometry in and add constraints relative to it. So it just makes it very easy to create my part with respect to this imported file, right? So very common workflow, I feel. A lot of times, I'd say more often than not, you're designing around something that you didn't necessarily create, right? Whether that's some kind of standard piece of hardware or some model you got from a vendor or customer, whatever it may be. Chances are you didn't create it, but you need to work with it. And this is an example where I might use that, right? So I can click extrude. Now I've created my simple flange, let's say 0.25, and I hit the green check. And now I've built my flange, and I didn't need to measure a single thing. Right? I'm just grabbing the values right off of the parts that it's going to be attached to. Now, the natural question with this is, well, what happens if those parts change? Remember, you can use derived for anything. It doesn't have to be imported geometry. And what if I wanted to change the original? How would this behave? And it is derived. And what I mean by that is when you insert it into another Part Studio, as long as everything's in the same document, it updates live. So if you decided to make a change to the original, let's do an offset here of, let's say, 0.75. So now I'm changing the outlet diameter on this housing, this casing, right? I'm going to do it to both sides. So we'll do another move face and click this face and make it 0.75. So now I'm changing the diameter on both the bottom and top casing. When I go back to my Part Studio, it will automatically regenerate. And the key to this is everything is in the same document, so it updates live. Now, you can also do this where you insert from another document, and then it would update whenever you tell it to. It gives you a little bit more control. So you kind of have the best of both worlds. If you don't like the live updating experience, just insert a part from a different document, and then it will be dependent on a version rather than the latest. But if you do like this live update behavior, if that's really what you want, then definitely make sure everything's in that same document. All right, so that's a simple example of the derived feature, and it's something that I think is worth mentioning because I think it's a real common workflow of just working around other models. Now, the next thing I'd like to get into is patterns. And I discussed this briefly earlier, but I wanted to get into simple examples of linear and circular patterns. Now, linear and circular patterns are very simple. You can pattern parts, you can pattern features, you can pattern faces. You can even pattern at the sketch level, which we're not going to cover here. And if you prefer that workflow, you can certainly use it. We're going to discuss simple feature patterns. And I think that's where most people get started. They want an easy way to just say, pattern this feature along this axis, or pattern this feature around this axis. Now, again, if you have any questions, feel free to ask them in the questions dialog here, and I'll make sure to answer them. Now, in the first example that I want to give you, it's just a simple linear pattern. And let's say, for instance, that I want to take, this fillet, this extrude, and I want to pattern it along a certain direction. I would just choose the linear pattern, right? Then choose the features that I want to pattern. In this case, I want to do a feature pattern of the extrude and the fillet, right? This boss here on the end. Now, an important step of a linear pattern is defining, here's the direction I want to sweep along, and you have to do some kind of a linear reference. It's very easy just to choose an edge of the model, but really any linear reference that you want, you can choose. So I'm going to say I want to pattern this direction, and I want the distance between them to be 25, and I want the instance count, let's say, at 8. So I want 8 of these instances. And you can see as soon as I do that, I get 8 of those pattern instances. Keep in mind, we're patterning the feature. So even if the geometry changes, the pattern will automatically update. So in this example, I have an up to next in condition for the original. That up to next in condition automatically propagates even if the geometry changes over the pattern. So it's intelligent enough to understand that I want to linear pattern this feature even if the geometry changes and needs to extend that geometry down, right? Is that a draft angle? Yes. This is just draft in the extrude command. So yes. We have a separate command for draft, but it's also built into extrude. But again, notice the draft is extending. The up to next in condition is being recognized even over the length of the pattern, right? Now, there's a lot of really neat things that you can do with patterns that I just don't have the time to discuss today. We have, again, done webinars on patterns in particular. That is definitely worth checking out if you haven't already. All kinds of cool stuff you can do with patterns. Patterning features, patterning parts, doing variables and patterns, and all kinds of very cool stuff. Now, that's a simple example of a linear pattern. And I'd also like to show you a simple example of a circular pattern. It's almost identical with one major exception. Instead of saying this is the linear direction I want to pattern, you're saying what is the rotation point that I want to rotate this pattern around. So a circular pattern, of course, means that it's patterning in a circle rather than in a linear direction. So I'm going to choose the circular pattern command from the toolbar, choose a feature pattern again, and I want to pattern this extrude and this fillet. Now, what's different about this as opposed to a linear pattern is instead of defining a linear direction to say this is what I want to pattern along, I define an axis of a pattern. Now, an axis could be an axis like we defined in our Revolve earlier, or it could just be any round edge or face. In Onshape, you can select any round edge or face, and it will automatically grab the center of that circular face, round, whatever it is, and define that as your rotation axis, the axis of pattern for your circular pattern. So you don't have to, create a line, or you don't have to. If you have a circular face, a circular edge, just click on it, and the center of whatever that is will be defined as your axis of pattern. And you can see here I've taken extrude 1 or extrude 2 and fillet 1 and created 3 more instances for a total of 4. You can see 4 here in the pattern command. So I hit the green check, and there we are. Questions. I have a confidential part which needs some specific curve on it using a sweep command. Can I ask you Onshape to with the same confidentiality? I have a confidential part which needs some specific curve on it using the sweep command. Can I ask you /Onshape to with the same confidentiality? I'm not sure I follow. Is there a draft angle? Yes. In the extrude command, there's actually a draft angle, and also when you do an individual draft command, you of course enter your draft angle. Is there a way to show axis like you can in SolidWorks? And I'm assuming you're referring to the temporary axis command in SolidWorks. We do not have that, but I will say that you rarely need it. I can't think of a scenario where you would actually have to have an axis as opposed to any kind of general line or round edge. Remember, you can use any round edge, any circular face, and it'll automatically grab the center. So we do not have temporary axis, but I also think we don't need it nearly as much as SolidWorks does. In a linear pattern, can you set the linear direction independently from an edge, like set in degrees? In a linear pattern, can you set the linear direction independent from an edge? Well, you wouldn't set it in degrees. What you would do is sketch a line or create something essentially that's has that angle in it. So, in the example of the linear pattern I gave you, I clicked on an edge. But if I didn't have an edge that represented the direction I want to pattern, I would construct some kind of a line. And I could easily draw a line, and give it that angle and then use that as a reference. How would you create a spiral pattern? Actually, I think, bear with me for a second here, I want to say that there's a feature for that. There might be a few ways to create a spiral pattern. You might be able to do that with like a variable in the circular pattern. Forgive me, I'm kind of going off on a tangent here, but I want to say that there was a spiral pattern feature created in feature script. I could be wrong. It's not 100% sure, and I forget what it would be called if it was. Come back to me on this. I want to say that I've seen this before. Maybe it's not a publicly released feature, but there is a feature script series of code that will do that. I'm fairly confident of it. I'll come back to this in the end. All right. So what I wanted to do. The last thing I wanted to cover here is variables. And I only have a few minutes left, but I think variables is a very important topic. And the reason I think it's very valuable is for two reasons. The biggest thing is a lot of users ask, is there a way to apply the same dimension to many different things and then change all of them in one place? Right? So let's say that I'm designing a part and, I have this wall thickness in the part and I'm constantly entering in, 3 millimeters, let's say. And, I'm entering in 3 and 3 in many different sketches. And it's just, this is this standard wall thickness I'm going to use throughout the whole part. Well, if I enter in 3 and 3 and 3, and then we realize, oh no, it should be 4. My uniform wall thickness should be 4. Then I've got to go back to all of those sketches and change all those values to 4, right? So it's not a very intelligent way to design the model because I have just these static values. And that's where variables can be used. I can create a variable, set the dimension equal to the variable, and then change the variable and control everything in one place. So that's one example where it's very useful. The second example that I would give, and it's another commonly asked question, is how do I make a dimension driven by another dimension or an equation of a dimension? Like, let's say that I want this value to be set to this value divided by this value plus that value. How would I go about accomplishing that? And the answer is you would create variables and then create your equation when you're entering in your dimension. And this is another way that we can kind of build some intelligence into the design so that as I change it, I don't have to change 10 different dimensions. I just change it in one place. And because of the way I've designed it, it automatically updates. So I think those are two really practical applications. There are many that I could get through, but I think in terms of the most commonly asked questions that I get, this is definitely it. How do I make one value set to everything so that I can change it all at once? And how do I set things equal to equations based on other dimensions? So I have a simple example of a flange here. And the idea behind this is, I want to build several different flange sizes. And, the flanges have a bolt pattern in them. So as I change dimensions, I want to ensure that that bolt pattern stays in the middle. And then I don't have to go through and change the 2 or 3 different values every time I want a new size. So this is an example where variables make a big difference. The key thing I would stress about variables is make sure that you've created the variable high enough in the feature list to use it. What do I mean by that? If I create a variable, you'll find the variable far right of the toolbar here. So I create a variable, and I'm just going to give it a name. We'll call it boss, right? So name boss, and I'm going to give it a value of, let's just say 10. So I'm creating, again, just giving it a name, setting it equal to a value. That's really all you have to do to create a variable. What you'll notice, however, if I accept this, is the variable is listed in the feature list as a feature. So What that means is if I decided to go back to, let's say, Sketch 2 and edit it, I can't use variable boss because it didn't exist at this time. It's history dependent, right? So a big tip in general, depending on your design intent, I think it's just valuable to grab your variables and drag them to the top of the feature list. Now, there are reasons for not dragging it to the top, and you can get into more advanced patterns by doing things that way. But for the sake of simplicity, I would say as you're getting started with variables, it just makes sense to have them at the top. There are, again, explicit reasons why we made this history based, and you can do a lot of really neat things with variables, basing them off of other variables and so on, but that depends on history. That's why it's so important. But a tip when you're getting started, make sure that your variables are above any feature that you're trying to use them in, right? Now, in this example, you'll see two variables I've created, right? So if we edit these variables, you see I have flange OD and pipe size, and that's really the OD of the flange and the inside diameter here as well. What's neat is I can change these variables with final on, another very good application of final. You'll see that it updates live, right? Notice, as I'm changing this outside diameter, the bolt circle for the flange is automatically staying centered between this diameter and this diameter, right? So no matter what I change the OD of this flange to, that bolt circle is always going to stay centered. The way we accomplish this is with an equation. And now you need to create variables to use them in equations, but once you do, it's very easy to define your dimension by an equation. So if we look at the bolt circle diameter, here's the sketch for that bolt circle. Bear with me for a second here. There we go. All right, so here's the sketch for our bolt circle. Right, you can see there's a construction circle that defines that bolt circle diameter. And if I double click the dimension for that, you can see it's driven by an equation, right? Which is flange OD, this variable, minus, went through too fast there, pipe size, which is this variable, the inside diameter, divided by 2 plus pipe size. Right? And what that gives me is a circle that's perfectly centered between the OD and the ID. Right? So it's an equation that drives them. Now, another thing I would point out is notice that the variable name starts with a hash symbol. Anytime you need to use a variable, you just double-click a dimension and type in hash symbol variable name. And then from that point forward, you can change that value here, right, without having to go into the sketch. Right? So again, make sure to insert that hash symbol, then type in your variable name, and you will be linking the dimension to that variable. Let me jump into the first sketch here just to show you what I mean. You'll see hash symbol flange OD, right? So again, variables very easy to create. Just a matter of giving it a name, giving it a value, and then punching it in. But it's very simple to give them equations, set them equal to each other, and so on. All right, so that is what I had planned. I see there are just a couple questions and some things I have outstanding, so I am going to stick around and make sure to get to all of them. But that's what I had planned for you here today. We have 2 minutes left, so again, ask any questions that you'd like in the questions dialogue, and I'll make sure to address them before we end things. But that's what I had. Thank you, everyone, and have a good day.